Okay, this is about cutting and touch on grinding at the end. Just a review what chip removal is. Sawing is a chip removal process. So remember these little pictures of the tool cutting the metal. And again, a little bit of a review that you have to, the harder the cutter, the can get hotter, but it can withstand heat better. And heat is the enemy of machining. Now you have sawing and you have shearing. Shearing is scissors that cut a piece of paper. Got a big shear up there. I'm going to show you videos on how it's used. Wire cutters, pinch wires apart. Those are examples of shearing. We're going to be talking about sawing. Table saws, band saws, chainsaws. I think I put up some videos that have some very interesting ways of cutting trees that don't involve chainsaws. But here's what sawing looks like. You got your teeth, you're moving your saw blade, it's going down a little bit, and it's cutting off the chips. Doesn't it look an awful lot like the standard cut from a like the milling and the lathe work, pointy thing cutting into material. Now there's a lot of terms dealing with sawing. The teeth, obviously you know what a saw looks like. I hope you do. I'll do a little show and tell. You've got pitch, which is in this case means the number of threads per or teeth per inch. Remember with screws it has to do with number of threads per inch. So here it's teeth per inch. Another term is kerf. Now when you run your saw blade through a material, you have to, you're going to leave a little space, and that space is called a kerf. And you have the teeth set, and so the tooth set is a way you have to have the teeth a little bit wider than the main part of the rigid part of the saw. A little bit more about that when I talk about sets. But what's left after you run your saw through it is called a kerf. You have, if you're dealing with wood, you have a crosscut saw or a rip saw, or actually most of what you would go and buy would be called a combination, because it can do both. But if you're really going to be doing handwork or precision work, you want to get a specific crosscut and rip saw. I'll mention that in a minute. And except for a Japanese handsaw that cuts on the pull stroke, you want to think of all saws as cutting on the push stroke. And I'll kind of explain what that means when we get into a little bit more specifics on the bandsaw. One of the things that you always want to do is make sure you have at least, preferably 3 teeth, at least 2 teeth on the material at any given time. If you can't, if we're getting in a situation where you end up with just 1 tooth on the material at a time, you need to get what would be a finer blade, a blade with more teeth in it. One of the videos shows this very dramatically of how this really makes a difference. And it really can make a difference if you have a skip tooth blade. Some rough cut saws for metals will have take out every other tooth. They skip it. It provides, if you have a really hard blade and you have a pretty coarse cutter, this can provide a way of keeping the heat down by not having as many blades in it. And you can imagine here, it would be very easy to get into a situation where you would only have 1 tooth on a piece of material. Now, I mentioned that all saws have to have a set. And that means that these teeth are going to point a little bit wider than the major part of the blade. You can see that with the The straight set, every other tooth points out just a little bit to give you a little bit more cut. The wave set, a few go in one direction and a few go in the other direction. Wave sets are very popular with hacksaw blades. I don't know why, but it is. You can get a raker set where one tooth points out in one direction, then one is straight into the middle, and then the next one points out in the other direction. It's a matter of preference, and when you have some experience, you can see that it makes a difference. I like, on metal cutting blades, I like the straight set, but like I say, you can't, it's hard to find hacksaw blades that do anything but the wave set. Oops. Now, bandsaws are pretty much a workhorse, and it's a continuous blade, runs around. You can have specialty things, the big round piece that's welded or soldered together. It's very versatile. There's a lot of ways you can do. You can do curves, or you can do straight cuts. With metal, you most often do straight cuts, but you can do curves with metal too. There's some videos on those. And here's a picture of a bandsaw like we have, similar to the ones we have. You can see, if you look carefully, the wheel unit inside the enclosure. You can see where it is, and it goes around, and the blade goes round and round. I'll do a show and tell with a bandsaw blade just to show you what it's like. The blade welder over on the side, a good industrial one will have that for metalworking, so that you can make your own blade, or when your blade breaks, you can fix it easily. Circular saws, if it's mounted underneath a table, it's called a table saw. Very rigid ones can be used for cutting metal, but most often they're used for cutting wood. The portable ones, handheld, developed by the Skill Company in the 1940s, revolutionized construction. And to this day, it's remarkable. You can't go on a construction site without seeing somebody with a portable saw, and they're called skill saws because Skill got it kind of like Kleenex is the generic name for tissues. You can also have miter saws and other types. And here's kind of a picture of it. You got that. This would be a miter saw primarily. You got your blade that spins around. There's a motor that does that. If it's metal, you can clamp it in. If it's wood, you can hold it by hand. And that's your standard saw. And imagine that as a separate piece that could be moved around. I brought this in as a bit of nostalgia. This is a automatic reciprocating saw, if there's a way to do it. And one of the first factories I visited when I was working in industry, a young guy, just a few years older than you guys, went in and saw a machine very similar to this. It was a bandsaw, not a reciprocating saw, but it was cutting off blanks like this diagram shows, fully unattended. It would automatically bring in the new material, feed it, and it did. The one that I saw even had ways of stacking this in, and the people said, yeah, they'd run it 24 hours a day, and it was the first machine that they had that ran lights out, because it did just keep cutting. And they want those little discs that they're going to convert into something else. And so it's nostalgic. You can have automatic saws, and it can feed the material to it all by itself. Next to the last topic here, one's broaching. It's a variation of a saw, and what it does in one pass, it can really cuts a groove. You don't generally cut through it. You might want to have a groove like a where you're going to have a key way, something to attach. You get a round part and you want to put a slot in it so you can put something in to make it hold together. You would broach it. And here's what makes it different. The height of the teeth is different. So each tooth cuts down a certain amount. And in one pass, you can cut what it would normally take several passes to do. It's got to be a very rigid machine. Last part is just to look at grinding. We're going to see it again in another presentation, but the way grinding works is very much like all these other things we've been looking at. You got your grinding wheel and you got a little piece that sticks out front and it pulls out a chip and pushes it. Eventually it breaks and a new piece is exposed, and maybe it's got a different cutting surface, but it does the different angles. That one, will, if it's got a negative angle, it'll end up breaking and creating a new place that has a positive angle, and the stuff just creates new chunks. Okay, that's it for sawing.